largest bank in North America with just over 2,400 locations, 1,600 of those being in the US and the remainder being in Canada. We have 85,000 employees and 22 million customers, and our footprint consists of over 23 million square feet of both retail and corporate. LEED is focused on being an environmental leader, and we've built a strong foundation by embedding environmental perspective across our business through these 4 pillars. Number 1, reducing our operational footprint, like finding ways to shed unnecessary space as we remodel locations, and designing new buildings to be the most efficient building possible. And LEED is one of the ways in which we are able to achieve that. Number 2, engaging employees and communities in the environment, like our TD Trees and Friends of the Environment program. Number 3, green products and services for our customers, like green insurance discounts for hybrid and electric vehicles. And number 4, responsible financing, like our green bonds, which finance low carbon projects. To dig even deeper, we focus on these 5 lenses to track progress against our goals as being as green as the TD logo: energy, water, waste, brand engagement, and health and wellness. As I mentioned before, one of our commitments is to reduce our environmental and operational footprint, and that means building the most efficient buildings possible. We've been very successful using the LEED platform in order to achieve these goals. Here is a snapshot of our LEED platform portfolio. We have a total, as of today, of 202 certified buildings. 191 of those are in the US, with 11 in Canada. 193 of those are retail locations and 9 are corporate locations. And as you can see, we have a variety of certification levels from platinum to certified, with the majority of our locations being gold. Currently, TD is building about an average of 25 to 30 new stores per year. And out of those, approximately 1/2 are inline urban locations, with the remainder of those being prototypes. The banking industry has certainly changed over the years and evolved, and we've had to do that as well. Currently, our prototype is 2,500 square feet, which is down from 3,800 square feet just 2 years ago. And we modify this prototype on an as-needed basis from Maine down to Florida. It's important to TD that we relate to our community, and although a large percentage of our building components do remain consistent. And most of our locations are open 7 days a week, and our net average electrical consumption varies greatly depending on the building, its age, whether it was an acquisition, and depending on the equipment that's in the location. As you all know, the USGBC gave us until the end of October to register all of our projects under the old LEED 2009. And one of the first things I did was I took a look at the pipeline of projects to make sure everything we had was registered. Wanted to get them in there and make sure we were covered. And since our pipeline of new locations had been dwindling a little bit, I wasn't expecting a lot of new stuff to come through, so I knew I had a little bit of time to play around with understanding what the new LEED requirements meant to our prototype. So I wanted to take advantage of that gap of time to look at a potential pipeline or a potential pilot project. So we ended up picking a New England location that wasn't scheduled to open until 2018, and we thought, let's use this location to really analyze the new LEED requirements and see what that means to our go-forward projects, what kind of impact it has. It just so happened that parallel to this LEED deadline, we were in the process of launching updates to our prototype anyway. We had some new exterior brand enhancements to make. We had some interior fixtures and furniture updates to make and equipment updates. So we felt like, what a great time to just add this extra layer of LEED into there. Let's look at this holistically. And there were a lot of benefits to doing it as one exercise. You know, if you look at it like a whole package, it took us a lot less time to execute. It cost us a lot less in soft cost, and we had a fully integrated design. So how do you do this? Well, we wanted to make sure that we had the best team at the table. So we put together a core team of subject matter experts. We felt it was extremely important to bring all of these folks, like my friends here at TLC, to the table before putting pen to paper. And this integrated approach saved us later on with time and making sure everybody had a voice. And I really can't thank the TLC folks enough for the work that you did. I know that you stayed up late some nights, Justin. Thank you. So once we had that team in place, we organized an all-day kickoff session. We literally started using the LEED V4 checklist as our tool, and we cut it up. We literally cut it up into pieces by category, and we pasted each one onto whiteboards, and we talked about feasibility of each. We know that there are prerequisites we need to meet, so we talked about those. We know that there are site-specific credits nowadays that we may or may not meet depending on where the bank is being built. Things like quality views and mass transportation. There were some credits that we expected just because we already do some of those things in our building, and then there were tons of things that were challenging, very challenging. So those items in the very challenging bucket, we had to talk about whether it was feasible or whether it wasn't. And then there were things like that were totally off the table. Building envelope commissioning is one of those. So we spent the day going through this exercise, and then we assigned certain tasks to individuals and sent them on their merry way, like our friends at TLC. We sent them off to do their magic energy modeling for us. And then we continued to plow through all of these items with weekly calls and bi-weekly calls and other types of calls. And it was a really extra exciting opportunity. And now I'm going to turn it over to Mark, and he's going to talk a little bit more about the difference between the old and the new LEED. Thank you.
So I'm Mark Gelfo with TLC Engineering. For architecture, I'm an energy services manager, which just means that I do a lot of LEED work and a lot of commissioning work and a lot of energy management work for TLC. Okay, sorry. So like Christina said, before we start talking about, or before Justin starts talking about some of the specifics of what we did from the design side and energy modeling side, I wanted to give you guys a little primer as to the major differences, kind of showing some of the challenges we needed to tackle in taking an existing prototype from the LEED version 2009 to LEED version 4. So under the old version of LEED version 3 or 2009, LEED was all about strategies, things that you do that you hope have good outcomes. So we do commissioning as a prerequisite so that we hope that the building operates more efficiently. You put in, recycling rooms so that you hope that people will actually recycle in the building. But under LEED version 4, it's all about performance, and there's a much bigger focus on documented, tangible, sustainable, no pun intended, performance, which is just mirroring really where the industry is going anyway. Building codes are going that way. Owners want documented, tangible performance metrics. So LEED version 4 represents that as well. LEED v4 is all about performance. And so I mentioned energy codes over time. You guys all know that the energy reference for LEED is ASHRAE 90.1, and this chart shows kind of how the energy code has evolved over time, 90.1 and IECC. And so under the previous version of LEED and older versions of a lot of states' building codes, you were about here. And with LEED version 4, and for instance here in Florida, when we adopted the latest edition of the Florida Energy Code and IECC 2012, which was based on, we moved to about here, which is a huge increase in energy performance requirements, about 19% jump in energy performance requirements. And when I talk about it, I say, well, we're not just going to get there by specifying LED lights and a magnetic bearing chiller. That's a completely different way we approach the design and construction of high performance buildings to get that 19% improvement. And that's really fundamentally one of the challenges that we tackled, taking the existing prototype for TD Bank and seeing how it could perform under LEED version 4. So LEED v4 on its surface looks very similar to LEED 2009. A lot of the credit categories have the same name. Sustainable sites got broken up into location and transportation and sustainable sites, so that's a little different. There's a new single credit for integrative process, but substantially it all looks and kind of feels the same. But underneath of it, there's a lot more to it, a lot more rigor, a lot more requirements. One of the nice things, I think it's nice, is that under version 4 there's more breakdown of, there's different rating systems. So the new TD Bank prototype is pursuing certification under LEED for retail, a specific rating system targeted at retail applications, which is substantially similar to the new construction but has some nuances to it. So real quickly, one of the focused on energy and water. One of the new credits is about integrative process. And again, on its surface, that sounds like, oh, we're going to have an integrative process and everybody will come together and we'll have meetings and it'll be great. And that is true, but the integrative process credit is really all about energy and water. And it's the things that we as commissioning agents and energy modelers advocate all the time. Early energy modeling to help inform the design process, and for that matter, doing an early water budget too to help identify opportunities to save water, to save energy, and at the very earliest pieces of the project, make sure those get integrated into the OPR, into the BOD, that gets documented and discussed throughout the project and through the entire process of the project, and like I said, helps inform design decisions. So that's a credit that we can apply and one that we're pursuing on this project. One of the big changes to LEED version 4 is, like I said, is a focus on performance. There's additional credits and prerequisites for metering and monitoring. In the water section, there's a prerequisite for building level water metering and some additional credits for water sub-metering, similar to what you'll see here in a second for energy. If you want to reduce the amount of water your building uses, you need to know how much it's using and where it's using it. So that's a new thing under LEED v4. The energy section is obviously what we're going to be talking about a lot today and where we spend a lot of our time. And a lot of the categories between, or the credits between version 2009 and 4 are similar but combined. And one of the big things, like I mentioned, is energy metering. Again, focusing on performance, you need that data, know how much energy your building is using and where it's using it to be able to document the building performance. And Justin's going to talk about this a little bit more here in a minute. But a prerequisite to have whole building energy metering, that's not too difficult. That's your utility meter. That meets that requirement. But additional credits for having detailed sub-metering for any loads that are more than 10% of the building's overall load, to be able to track that and record it, tie it into the BAS, so that you know, again, where you're using energy and how much, so that you can make sure the building's operating the way you intended it and target additional energy conservation measures as the building continues to operate. Indoor environmental quality is similar to version 2009 with more focus on daylighting and quality views, and the interior lighting section is much more focused on performance again, and we did look at new lighting as part of the energy analysis. So Christina mentioned a little bit about the process that we went through and the kickoff meeting and talking about the different LEED credits and using the checklist. After that happened, there were bi-weekly check-in calls to go through each of the credits and talk about the status of each of them as we were researching and doing our due diligence on those credits. And you can kind of see at the bottom there the magic that we did was kind of all clustered there towards the end with lighting redesigns, and we did solar analysis and commissioning analysis and a little bit of the HVAC redesign in combination with energy modeling, a couple rounds of energy modeling that Justin's going to talk about in detail. So it seemed like it was a lot of meetings and then a whole lot of activity for us kind of right at the end there to help make those decisions. So some of the challenges or opportunities very quickly from going from version 2009 to version 4. I mentioned the sites, location and site was something that we struggled with a little bit in that process, which we're not going to talk about today. That's a different presentation. Same with materials. If our architect was here, she would talk about the challenges that she went through trying to find the materials that met the new materials requirement in version 4. I mentioned the increased thresholds every time there's a new version of LEED. The thresholds step up. It's a leadership standard. It's not a status quo standard. That's the whole point of LEED. It's leadership in energy and environmental design. So that's LEED's job. It's to push the envelope. It's to raise the bar. So it gets harder each time trying to push the industry forward. And that's always a challenge when you move to a new rating system. Plus the fact that not a lot of people on the team had really much experience with LEED version 4. So everything was new and everything had to be researched, and you kind of feel confident that you think you know what you're doing because the prototype had been all gold certified, but then you got to do a whole lot of research to kind of like starting over. So with that, and let Justin talk about what we actually did.
All right, I'm Justin Mulhollan. Was the project manager for TLC for this project. We started with the 2013, 2012 vintage of the prototype. Had a lot of good features in here. I'm just going to plow through these real quick. It had a solar PV, it has daylighting control, it has a very good glass. All these things that were very good compared to the ASHRAE 2007 baseline. Now we're up against a new baseline. So we're trying. They don't go as far as they did before. So where we really focused our energy was on the HVAC system, which was existing was basically the building was split up into 3 constant volume units with a heat pump for cooling and gas-fired heaters, heating coil. And they also used zone dampers with a bypass damper to give you some zone control. So it gives you a little bit of that little zone control, but it's not operating like a VAV. You still have a constant volume fan to deal with. So that's where we started. We had this was our HVAC system. We have a lot of good features in here, but now ASHRAE 2010 comes along. The glass baseline gets better. Daylighting control is now required, and then they're not getting us as far as we need to go. So we focused on the main energy consumer in the building, which is the HVAC system. We started with TD to understand what their goals were. What's important to them. It's got to be scalable. They're going to roll out this prototype from Maine to Florida, which is a wide range of climate zones. So you got to come up with a system that's adaptable. The other part of it that ended up being a main driver on the project was maintenance. They have a maintenance contract. It's based on the systems that are in the building. So you change the system to something that's considered more complicated, your costs go up. And that's something that's hard to quantify, and it also impacts the life cycle cost greatly. And then also the target was a EUI of between 75 and 80. So those were where we've started from. So we tried to come up with options. Now you're working with a 2,500 square foot building. It's not a ton of different systems you put in or normally see in that size of a building. So the first option was, well, what if we just make the systems that are there more efficient? What's there is a 5-year-old selection. There's equipment that's gotten more efficient. So let's look at that, because that's great. A lot of the impact to the structure doesn't have to change. The building layout, ceiling space, nothing has to be really thought through there. So that's good for the design side of things. It's also good for the maintenance side. So that was one option. The next option was changing it to a central VAV, which is unusual for a building of this size, but is more possible now. There's a lot more manufacturers that are producing smaller units with variable compressors. So this unit was about 7.5, 10 tons. I think we ended up at 10 tons in the final design. And we were able to find some manufacturers that actually have variable compressors. So you're actually able to do true VAV operation with your system. So that was on the table. And the reason we chose that, and you'll see in a later slide, is when you model the baseline, the existing prototype, the main energy consumer was the fan energy. So we wanted to attack that with newer technologies. And then, of course, I think with any building, when you're looking at energy efficiency, high performance, VRF is considered. I mean, I've seen that considered on a lot of projects for those reasons. Basically, the way we attacked this was energy modeling. You know, obviously there's two compliance paths. You can do prescriptive or you can do performance. Prescriptive, while you can document compliance with LEED and the energy code, you're not necessarily going to be able to hit every requirement in a design that has to go through all the different climate zones up the East Coast. So we went down the performance path and we did energy modeling. And an important point with energy modeling is that not all energy models are the same. You have to understand what your purpose is for your energy model. And that came up on this project specifically. So on this scale, you have your existing buildings where you calibrate your model, and then you come up with energy savings measures against that calibrated model. So you model the existing building, you're trying to recommend energy saving solutions to the owner. There's design models that go through the different phases of design to LEED compliance, and then there's models that are used to try and predict energy usage that are kind of blended with the calibrated model at times. So our model for our analysis, somewhere between the concept and schematic level, concept design model. It was high level, but we sized the equipment. We knew we were going to do a design on this building, so we went ahead and ran our load calc, sized it appropriately, and then did our comparative analysis. So we're not as concerned about the process loads and all that. As long as we're making sure the system's sized right, but how they operate doesn't matter because it's consistent. So we're looking to compare the HVAC system only. At the same time, TD was working on a net zero building with a separate engineer, separate energy model, and they're trying to get to net zero. So they went through the old prototype, detailed every piece of equipment in the building. They detailed the schedule of operation for each piece of equipment. They went through and measured, and they calibrated the model against the old performance, updated the design, and they were trying to get to net zero, so they needed to really know exactly what their models, what their loads are for everything. So then when at one point, we presented our findings to TD, and the other engineer at the same time was presenting their results for the net zero, and the process loads didn't quite line up. The lighting was a little different, and the questions was, why? Why are they different? Because shouldn't the models be the same? And we got on the phone with the other engineer to talk through it, and there was no insults about whose model was better, thankfully. And we basically came to the same conclusion, and we presented that to TD and said, look, they had this goal. They have some good information. We will incorporate that into our model. For load sizing, equipment sizing, knowing every piece of equipment is not necessarily as important. But for theirs, when you're trying to get rid of all the energy usage, you need to know everything. So we got some good things from their model to include in ours, and TD was happy with the updated results, and we moved forward from there. So just the key is just to understand what your energy model is. If you're working for the owner and make sure they understand what their expectation is for an energy model. But before we went to the HVAC system, we started with the building envelope. There was a couple things that we were asked to look at. One was the insulation existing was R30. They want us to look at whether we went to an R40. Would that be any benefit? No, there wasn't. We also put out a suggestion of maybe you go down to R20 and save yourself some money. And overall, that money wasn't worth saving, and the impact the energy wasn't great. But when we're trying to get this thing certified, we can't really cut out any little bit of energy savings. We looked at increased wall insulation, different wall construction types. We looked at improving the glazing, a couple of better glass selections, and then the other thing that TD had already worked out with the architect and their lighting supplier was changing to LED lights. The old model had all compact fluorescent, so they they already had that package. We modeled it just to prove out what the savings were. So once we got all that in place, then we went into comparing the HVAC systems. So this is what I mentioned before about the pie of the energy usage, and it was constant volume, DX. So your fan energy was the big consumer. So we looked at that. We went to then we modeled to the increased efficiency option, and it helped a little bit. The fan energy still wasn't addressed because it's still constant volume. So this one didn't get a lot of traction. You know, it was definitely attractive from the maintenance side. They said, you know, if it's not broke, why fix it? So that was one of the benefits of this issue. Is, you know, they know how to maintain it. They know what the issues are, but it's not really. There's no actual real energy savings. You still have a little bit of controllability issues just because you have zone dampers instead of just VAV, and you're not ramping the fan down and all that. But so then we went and modeled the VAV option to kind of tackle the fan energy portion of it. So saw the energy savings come way down, and one of the reasons for that was the ASHRAE 90.1. If you look at Appendix G, which dictates your baseline that you're comparing to for code compliance and LEED, the baseline system, the existing prototype, and the baseline are the same thing. So now we're comparing it, and we're addressing that fan energy, so our savings went down quite a bit. We have a little better zone control. We're a little more tighter on operating the system only to the cooling that it needs to be, because we have the system we based it around was a Daikin unit that has a fixed compressor that's just on off, and then they have the variable compressor. So that allowed us to get a little more precise with our temperature controls. And one of the added benefits was that it's a single unit to maintain instead of 3 different units and go into 3 different locations to maintain things. So there was a little bit of benefits there, and it wasn't as scary to the maintenance staff because it's all equipment they know how to maintain. We had to modify the roof structure, and it was definitely a cost increase. So that was something that had to be dealt with, and Christina had to go get that kind of approved to go that route. But that was what we looked at for that option, kind of weighing the pros and cons. We did look at VRF, and you'll see there's a kind of an asterisk next to the numbers. And the reason we put the asterisk next to those numbers is, one, modeling VRF is hard. So I can't vouch for those results, because before we had the time to fully vet it, when we presented VRF as an option to the maintenance staff, they had a lot of bad experience with VRF previously. They probably got some of the earlier versions of VRF, a lot of compressor issues. They just didn't want to get into that again. And then when you're talking about rolling this out to potentially 20 new locations, they're just thinking headache, and they were very strongly against it. So we put an asterisk there because we didn't fully vet that model at that point, because it was so clear that maintenance was not going to allow that to go. We didn't really go through it. But there's a lot of benefits to VRF. I think the technology is getting better and more reliable, but it's the first cost, and maintenance is always kind of the biggest cons that usually stop those ideas. So we summarized this. Christina ran it through her leadership to get it approved. And you see one interesting thing on here when you look at the models. You'll see when we went to VRF, the potential lead points go down. And that was the reason for that. If you look, again, going back to Appendix G in your baseline system selection, when you switched from, we have gas heat in all the other options. When you go to VRF, there is no gas. It's all electric. So now your baseline changes from the baseline system we talked about to a heat pump system, which is more efficient, and it ate away at some of our LEED savings. While the real world savings were there, the LEED savings weren't necessarily as good. And so we ended up going with the central VAV, and then TD has initiative to get all their buildings on the same control systems. They've piloted a brand called NTouch, which is made for small retail buildings, a lot of metering capabilities, and they're able to integrate the packaged unit controller for the RTU with the VAVs and a lot of flexibility in the energy metering. So now they have a building with the central VAV and all the different meters in place that they can really drill down later on if there are problems with the energy consumption and figure out what exactly is going on. So turn it over to Mark. You can talk about the commissioning for.
So TD Bank, they had obviously been commissioning all of the banks because they're LEED projects and because it's the right thing to do, and they were seeing benefits from that. And obviously you guys know that the commissioning requirements in version 4 are different than they are in LEED 2009, and it kind of goes along with a lot of the energy codes that are changing as well to require a certain level of commissioning. So we kind of looked at that process, and I like to kind of include this this slide to talk about different areas of the country are adopting different levels of the energy codes and IECC versions that require a certain minimum amount of commissioning, which gets that ball rolling anyway. But we did a kind of a gap analysis between the existing commissioning scope and contracts that TD had under the version 2009 and what's required under version 4. And that's what this slide kind of tries to show, is what's in green is kind of what was new and what was different and what was added in version 4 in the fundamental commissioning and enhanced commissioning. Without going through that, basically it just moved. In version 4, we moved some of the requirements, such as doing design review from enhanced into fundamental, added requirements for reviewing the enclosure, doing envelope reviews into the fundamental phase, not full commissioning, but just review and inclusion in the OPR and the BOD, and then inclusion of a facility's O&M plan and recommissioning plan into the fundamental requirements. Enhanced commissioning, enhanced base piece stays the same, but what was previously measurement verification is now an option there. And then Christina also mentioned the envelope commissioning is an option in full envelope commissioning. Testing is an option there, which they decided not to pursue. So that was an important piece to identify that gap in the requirements from what they were doing to what they needed to do now. One of the other pieces that we looked at had to do with renewable energy, and TD Bank had been doing renewable PV on all the new banks, all the prototypes for a long time, usually on the canopies, but the first net zero bank was in Fort Lauderdale, and Justin mentioned another one that was going on. How many net zeros?
We have one.
Just the one?
One right now, probably not.
Okay, good. So, so we did an analysis for them to look at options for what theoretically could we do and what were the different levels that we could look at for optimizing the amount of PV on the bank, kind of a theoretical exercise, compared to what the canopy, what the original prototype had was just on the canopies, looking and comparing the amount of PV to the HVAC options that Justin was just talking about to both maximize, looking at maximizing the number of LEED points, maximizing the actual output of PV that we could get, get for the building, and see where we're at, and see where we were at, and just standardizing on kind of this 275 watt module. This plan on the right shows the roof plan, where we did an exercise to see how many panels could we just jam onto the roof and still leave a reasonable amount of space for some HVAC equipment and walking around, and just as that theoretical maximum exercise. And this chart kind of shows the outcome of that. So the first 3 lines there are looking at our different HVAC options that Justin mentioned, the current prototype with the DX, the central VAV, which we ended up going with, and the VRF, compared to the amount of PV that they had on the original prototype, which was about a 9 kW system, nominally, to see what that looked like from a percentage of overall building energy usage and number of LEED points. And that's why the VAV is highlighted, because that's the option we ended up going with. And then we looked at, okay, what would it take to maximize the number of LEED points? And that's the, what, fourth line down there. And what size system would that be? And that would be quite a large system, 90 panels, 24 kW, to maximize both the renewable energy credits and to help maximize the optimized energy performance credits to get us past the 19 points maximum. And then I mentioned what could we physically actually put on the building, which was the 50 panels on the roof. So maybe we couldn't actually get 90 panels and get that theoretical maximum. So it was just an exercise just to see what was theoretically possible. And at the end of the day, I decided to pretty much just keep the prototype design as it was with the PV panels on the canopies. But I thought it was a fun exercise, but you know, that's just me.
So I'm going to wrap it up because I think the question really is this scalable? And, you know, we're still figuring that out. What you see up here on the screen are the 2 scorecards as they stand for the 2 pilot locations. I mentioned we had 1 pilot, but what ended up happening was we had this new project added to the pipeline. It's a super rush project in Stuart, Florida. We weren't expecting it to come, and now we have 2 pilots. So again, because we missed the registration deadline, all of our new projects need to be registered under LEED v4. So now we have 2 pilots underway. And we're basically hovering in the mid-40s. Definitely something that TD is not used to. We're used to being spoiled in the high 60s, low 70s. Like I had mentioned before, a majority of our locations are gold certified. So, you know, we're happy to be in the certified level. This is still ongoing. We may get lucky and bump up a couple points and be hovering about silver, but at this point, we expect both locations to at least achieve the certification level. We're anxious to see how the USGBC review goes. We have some good partners there who we've been working with and helping clarify questions. So it's definitely a learning curve for us, and we hope to take this information and influence our specs and our templates going forward for future projects. And we'll definitely learn as we go. For next steps, we plan to document our learnings. Understanding the associated cost is important to us. You know, we've raised the bar, and as Mark said, LEED is raising the bar on us. So what does that mean financially to the bank? We need to understand those costs. So we plan to track that. We plan to utilize the information that we are gathering from our Smart Retail Controls pilot, really understand how our energy model is working in relationship to reality. So we're excited about that. And, you know, we plan to socialize these results internally and see, you know, what that means to our business case as we go forward. But as I said in the beginning of our presentation, you know, TD is committed to sustainable buildings, and, you know, we're really happy on our journey so far. And we do appreciate you taking the time to join us today and to share that journey.